All right, let's look at how we can find equations of a line. The equation can take many different forms, but the basic ones are the vector form, the parametric form, and the symmetrical form. To find the equation of a line, we need a so-called direction vector and also need a point. Once these two pieces of information are given, then it's pretty straightforward. So let's take a look at how we're going to find the equations of a line. The first one, find the vector equation and parametric equations for the line. And the line passed through this point, P over here, is 3 and 5 and 1. And parallel to the vector, that means we have this vector over here. We have 3 and 4 and negative 1. So the vector form R over here is equal to R naught plus TV. And that's going to be equal to R naught is simply the point. And that's going to be, now we turn it into a vector, okay, and passing this point. And then we plus T over here. And then we have this V factor over here. We have 3 and 4 and negative 1. Okay. If you prefer, you can write down something like this. This is going to be 3 plus 3t 5 plus 4t and 1 minus t. Or you can just write down something like this. 3 plus 3t I plus 5 plus 4t j and plus 1 minus t. Okay, so that would be your vector form of the line's equation. Or parametric equation is essentially already there, so we can just extract the coefficients out, and then we can say x is equal to 3 plus 3t, y is equal to 5 plus 4t, and z is going to be equal to 1 minus t. Okay, so that's the parametric form. Okay. Now, how about the symmetrical form? We just put the vector, direction vector, in the denominator. But remember, we have two equations. So it's going to be x minus 3 over 3 is equal to y minus 5 over 4 and z minus 1 over negative 1. We really have two equations. If you try to look at them, and that's going to be x minus 3 over 3 is equal to y minus 5 over 4, and y minus 5 over 4 is equal to z minus 1, negative 1. Okay? So these are the equations, different forms of lines equations. Let's look at, the problem 2 is already solved, so we are done.